Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to the EV Components Review channel. This is going to be a two-part video of a comparison between the KO Pro / FSPEC power stage and the EBMX X-9000 power stage. I've got to do it in two videos because there's a lot of things to cover in here to explain why one versus the other is better. This has been requested at least a dozen times in comments on Facebook and on YouTube. The folks from EBMX, they have wanted me to do it because it just really shows just how excellent this EBMX power stage is. And yeah, I can't say I blame them. I'd want to brag too for something this good. So anyway, let's get into that. And I will break this up into two sections. And I'm sure that this is going to bring the KO people out of the woodwork like a wild nest of hornets, just wanting to sting me alive for this, because I'm going to show just how awful the KO power stage is and just how good the EBMX power stage is. And that's just how that's going to go. This is called excellently good engineering, and this is called horribly bad engineering, and those are just facts. That's not something that I make up. I've been doing electronics repair since the late 1970s. I kind of have a clue what I'm looking at when I look at stuff like this. Not some noob that just flew off the bus last week from wherever and decided I'm going to start making teardown videos. I actually have an idea. I've been doing electronics repair for much longer than most of you have been alive. So anyway, let's get into it. Alright, so the first thing I want to do is a couple of comparisons of materials, just to show you what beefiness is versus flimsiness. Okay, so let me turn this around so we've got the same perspective on both of them. Okay, so here is your battery minus and battery plus on the KO Pro / FSPEC power stage, and here is battery plus and battery minus on the EBMX X-9000 power stage. So here is a micrometer. And just so you can see, it is zeroed out. Oh, there you go, zeroed out. And it's reading millimeters. So I'm going to read the battery plus, and then I'm going to read the battery minus, and then I'm going to do battery plus and battery minus. Just the width. And that's 11.96 millimeters. And that is 11.92 millimeters. I'm going to try that again. It shifted a little bit. Yeah, 11.91 millimeters. Let's do these. And that is 14.01 millimeters. And that one is 14.02 millimeters. So let's be generous and say those are supposed to be 12 millimeters and these are 14s. So obviously it's, 2 millimeters thicker just in diameter. These are brass and these are copper. And copper has a significantly lower resistance than does brass, and it also costs a lot more. Brass is much thinner, and it's also not anywhere near as much, and these are copper and much beefier. Okay, so you know what this is, and now let's do the same thing for the base of these. So I already know that they're 14 millimeters wide because we just measured it, and that copper bar is the same width as the cylinder portion. And this right here, I'm getting there. Got to get right on the edge of that and get to the edge of that. There we go. 50 millimeters. So this is 50 millimeters wide or 50 millimeters long by 14 millimeters wide. And give me a second, I'm looking at my calculator. There we go. So that's 700 square millimeters in this entire space here versus this, which is, well, obviously way less. 700 square millimeters of copper surface area to the power stage on here versus just that. So this is going to conduct current significantly better. Yeah, way better. Go back over here again. There we go. Okay. So, by the way, these little pieces of copper right here, they're also the same width and length as are these two for the battery plus and minus, so 700 square millimeters. You know, that's on everything here. So 700 square, 700, 700, 700, 700. Whereas for here, let's bring this over. Set that up there. So here is your KO Pro / FSPEC power stage, and we have these little copper bridges, and they are 6 millimeters wide, 5.96 millimeters, and it's really hard to measure the base of that thing, so I've kind of got to get in here. But anyway, they're just about 2 millimeters wide. So you've got 6 by 2, so that's 12 millimeters by 12 millimeters, so 24 millimeters of, or 24 square millimeters of surface area at the base of these versus 700 square millimeters for everything on the EBMX controller. Yeah, just physical contact area alone between any of the studs here and anything on the circuit board is so much higher on the X-9000 than it is on anything here. You know, whether it's brass studs soldered directly down the board, or it's those little tiny feet area here for those bridges. Yeah, this is, yeah, it's got it beat by whatever that is, 200 to 1. Yeah, it's just so much more surface area, you know, especially for these. That makes it really look bad. Okay, also, here is your phase bus through here, and here, and same thing for here. And here is your big hunk of copper phase bus times 3 on here. And these are 3 millimeters thick by 14 millimeters wide by 50 millimeters long. And here you have nothing. You have circuit trace. That's it. No copper reinforcing of any kind in the phase bus. About the only thing that I can say that is some kind of a so-called saving grace for KO Moto is the fact that the distance between these MOSFETs is less than these ones. So I'll grant you that, and let's actually measure that. See how much that actually is. So edge to edge of MOSFETs, that's not quite there. Here we go, 22.5 or so millimeters. Whereas these guys are, yeah, about half the distance. It's about 10.5, 10.7 millimeters. So yeah, it's definitely much closer together. But that's no excuse for no copper reinforcing. It's just simply lacking because, well, copper is expensive and they didn't want to spend the money on it. Whereas EBMX said, we're not going to spare any expense. We're going to make this thing beefy as can be. And so, yeah, they moved the MOSFETs a little bit further apart just so they could put this monster piece of copper in between them. Yeah, it's a significant improvement. And then the bridges on here, yeah, I can only estimate the mass of these because I have some copper strap very much like this. It just doesn't have the holes in it, so it's actually heavier than this is, you know, which means more copper mass. So that's what I used to estimate the longest bridge. So it goes from here, and where's that block? There it is. So this would be sitting approximately like right there. So that longest bridge, which goes from here over to here, that one bridge, and, well, I have it away, that one bridge weighs more than my estimations for the entirety of all copper on here. That one bridge that goes from here to here weighs more, aka it is a significantly larger hunk of copper than is all of this copper on here. And I'm doing that based on an estimation based on copper that in fact has no holes in it, that is also 6 millimeter wide of the same width in a spool of strap that I have. So that's what I used to estimate that mass. And that one bridge has more copper in it than all the copper on here. Yeah. All I can tell you guys is, oh my God, this is so amazing, and oh my God, this is so horrible. Okay, let's go on a little while further here. All right. These studs right here, these raised features, they aren't current carrying. They only bring battery plus and battery minus up to the DC board for ripple filtering. They're not a current path. They do carry some current, but it's not like the entire pack current. Whereas in the case of the FSPEC/KO Pro power stage, they do. So here's where battery plus comes in, and there is a thin piece of copper through here that's 8 millimeters wide, but it's just trace thickness. It's not very thick, and most of the current carrying isn't through that. It's actually up above. It's on that on the underside of the circuit board. So you basically come in here, you spit it out here, and you bring it up those brass studs, back over there again, and back down again. It's a really tortured battery plus path. It's an awful battery plus path in every possible way. So, and again, all this stuff is just on standard circuit trace thickness, and it's really thin around here too, so it's a real bottleneck there. Whereas 100% of battery plus and battery minus on the EBMX controller is through 2 copper bars, and these are 6 millimeters thick, 14 millimeters wide. Yeah, big chunk of copper, and it's end to end, and this is the current path for both battery plus and battery minus. There's no tortured current path. It is as direct as you can possibly get it, straight from the terminals, straight to where it needs to go. And these little pads right here, the only job they serve is to get battery plus and battery minus up to the large capacitors. That's it. They don't do any current path at all. Their job is just to get battery plus and battery minus up to the capacitors for ripple filtering. Whereas here, that is not the case. A major piece of the battery plus bus is up on the underside of the power stage. So I bring this up, and I want to make that super clear for one very, very important fact. There's 2 of them, and there's 3 of them, and these ones aren't even current carrying, and they are 14 millimeters wide. We already know that, and they are try that again. Yeah, 3 millimeters thick. Well, it said come out 3.10, but I'm just going to say it's 3. All right, so these brass studs, let's see how wide they are. So they're 10.8. Let's try another one just to make sure. Yeah, 10.8, 10.9 millimeters wide. So they're already, significantly smaller. These are 14 millimeter, and these are 14 millimeter, and these are 10.5, 10.8 millimeters. And then the thickness of them and their brass is 1.4 millimeters. Let's see if I can't get down in a little bit better. Okay, there we go. 1.5 millimeters. Try that one more time. Yeah, 1.5 millimeters thick. So the wall thickness here is 1.5 millimeters. So literally half the thickness of these, and these are not current carrying, and these are. So much less surface area here, and they're brass. Much less surface area, and they're brass. So this is a tortured current path, and a very poor one, and this isn't even a current path, and it's excellent. I can't help that things are what they are. EBMX did a magnificent job in their power stage, and KO, oh my god, this is an absolute joke. Alright, I'm going to stop there, and we're going to talk some more in another video. There's more to cover.